Hello everyone, welcome to our daily physics problem, day number 23. Today we have an incline with an angle. There is an L-shaped groove with a mass m, ball stuck in it and accelerating downwards along the incline. It takes t seconds for the ball and the groove to reach the ground. What is the expression for the coefficient of friction between the groove and the incline and the pressure force on the vertical parts of the groove of the ball? We know the length of the incline is s. And we need to solve two things, the coefficient of friction and the pressure force. So I want you to pause the video, try your own. After you try it, come back to the video and we'll show you how I did it. So welcome back guys. So first, let's lay out all the forces here. First, we can see there are two gravitational forces, one acting on the groove and one acting on the ball. Then we know because the groove is accelerating downwards, according to the groove reference frame, there have to be an inertial force pointing in the parallel direction opposite to the acceleration of the groove, ma, exerting on the ball. Then we have friction. Then we need to solve for the acceleration, or the acceleration of the groove. We know a is equal to f divided by m. Then we know the f equal to the gravitational force times the sine minus the friction force times a cosine, minus the friction force, and divide by the mass. Then we get g times sine theta minus cosine theta mu. Then also from the kinematic formula, we know it takes s distance and t seconds to get down the ground. Then we can solve for a is equal to 2s divided by t squared. Then we equivalent to our original expression. Then we can solve for mu. Then we solve and simplify some function. We get mu is equal to tangent theta minus 2s divided by t squared g times cosine theta. And that's our first solution of the coefficient of friction. Then let's zoom into the groove and the ball. Let's discuss the pressure force on the groove, on the vertical part of the groove. So we know there are four forces acting on it. Two normal force and one gravitational force and one inertial force acting on the ball. So acting on the groove from the ball. So let's balance the force here to try to find out the relationship between n1 and other things, because n1 is the normal force, the force that we need to solve, the pressure force that the ball exerts on the incline. Then we know n1 plus ma times cosine theta, because this angle is theta, is equal to n2 times the sine of theta. That's in the horizontal direction. In the vertical direction, we have mg is equal to ma times sine theta plus n2 times cosine theta. Yes. So then we will get solving for n1. So now we have expression. We can see both terms have n2. Let's try to cancel out n2. From first term, we know n2 is equal to n1 plus ma times cosine theta divided by sine theta. From the second expression, we know n2 is equal to mg minus ma times sine theta divided by cosine theta. Then we can solve for n1, because since both expressions only have one n1, then we simplify the equation. We get n1 is equal to mg minus ma sine theta times tangent theta minus ma cosine theta. Then n1 is equal to mg tangent theta minus, let's put these two expressions together and factor out the m, and let's move it out of the cross, and ma times sine theta times tangent theta plus cosine theta. Then we know n1 is equal to mg times tangent theta minus ma times sine square theta plus because we common denominator equal to cosine theta, cosine square. And we know sine square theta plus cosine theta square equal to 1. So we can simplify it furthermore. And we plug in a is equal to 2s divided by t squared. We got our final solution here. And that's for our normal force.